Hello students, 8th grade math, unit 3, lesson 2. For today's assignment, you must have pen and paper or pencil and paper ready because you will need to take notes today. Your notes will be graded. I want to see your handwritten notes. After the assignment, take a clear picture of all of your notes and submit them to the Google Classroom for credit. You must take notes with this assignment. Okay, let's get started. First, have you got your pen and paper ready? Go ahead and put a title on there. This is 8th grade math, unit 3, lesson 2, and this is the practice. Each lesson has a lesson and practice. Okay, let's go on here. Let's get started. Problem number 1. Problem number 1. The tortoise and the hare are having a race. After the hare runs 16 miles, the tortoise has only run 4 miles. Say that again. After the hare runs 16 miles, the tortoise has only run 4 miles. Okay, what's the problem? Sounds okay to me. I'm slow too. It says, the relationship between the distance x the tortoise runs in miles for every y miles the hare runs is y equals 4x. Graph this relationship. Okay, so look at the y-axis. What is it labeled as, and what are the units? The y-axis is the hare distance. So why don't you go ahead and make a note of that? That y equals the distance of the hare. I put D, but you know what? I think I'll just put like hare. Is that okay? Okay, what does x equal? Look at the axes here. X equals the tortoise distance in miles. Oh, I want to make sure I write down the units. So write that here. X equals tortoise. And I'm sorry my handwriting is so messy. I have this pen tablet that is very difficult for me to use, but way better than a mouse. Tortoise's distance is also in miles. I'm going to use MI for miles. Please write the units in your notes. That is very important that you know what units you're talking about. Otherwise, you'll be confused later. Okay, what else should we put in our notes? Well, it says here, after the hare runs 16 miles, the tortoise has only run 4 miles. Well, they're kind of giving us coordinate points. It means, not y equals, sorry, I'm just warming up here. The coordinate points are y equals 16, but I want to put it here, and the x value equals 4. So they gave us a set of coordinate points right there. After the hare has run 16 miles, the tortoise has run only 4 miles. Okay, I think we're going to need to make a table to help us with this. So let's go y here, and the y equals the hare in miles. I'm just going to put h, and then the units mi. And on the other side of my table is x, with sloppy handwriting. X equals, now I don't want to say t because that can be confused with time, so I'm going to say tortoise though, it's short for tortoise. In miles, I'll abbreviate miles with mi. They told us that when the hare had run 16 miles, the tortoise had run 4 miles, or walked, I guess. It says runs. 16 miles for the tortoise, 4 miles for the hare. Okay, here's some more information here. The relationship between the distance x the tortoise runs in miles for every y miles the hair runs is y equals 4x. Well, look at that. They gave us the equation of this proportional relationship. Now, we could just go straight to the graph and graph that if you know what it means. Now, this 4 here equals our proportional constant k. Remember that proportional relationships are in the form y equals kx. I'll go ahead and type that here since my pen tablet is so messy. Y equals kx. So this k is the slope of the line, or the proportional constant. Now, if you're not sure or you don't believe me, I can prove it. Okay, so we already know that the hare runs 16 miles for every 4 miles that the tortoise runs. Go ahead and put this in your notes. Let's make a ratio. For the hare, it's 16 miles, and for the tortoise, it's 4 miles. Put this in your notes. This is going to be your proportional constant. It means that for every 4 miles the tortoise has run, the hare ran 16 miles. And we can simplify that to 4 miles over 1 mile. And this means for every 1 mile that the tortoise runs, the hare has ran 4 miles. In other words, the hare is 4 times faster. So here is our proportional constant. Now, let's say that the tortoise ran only 1 mile. So I'm going to put 1 for x. The tortoise has run only 1 mile. How many miles has the hare run? The hare has ran 4 miles. Let's say the tortoise ran 2 miles. How many miles has the hare run? Well, that'll be 2 times 4, 8. 8 miles. And what if the tortoise has run 3 miles? Well, for every mile the tortoise runs, the hare runs 4. So you can do the math real fast in your head. If the tortoise runs 3 miles, then 3 times 4, the hare runs 12 miles. These are our proportional relationships. 4 to 1, 8 to 2, 12 to 3, 6 to 4. All of these are proportional. Now, we can graph these data points right on that graph that they gave us. But they also gave us the slope of the line, which we can see as y equals our constant 4 times x. Don't forget, y is equal to the hare's distance, x is equal to the tortoise distance. Okay, let's say that the tortoise has run 10 miles. Now use this equation to find out the distance of the hare. Just go ahead and enter 10 in. 4 times 10 equals, oops, I forgot parentheses here. 4 times 10 equals 40. Put that value into the table. I'm going to look for that in your notes. Okay, so in your notes, you have this data table here. Hopefully yours is a lot neater than mine. I hope your pencil is more comfortable than my pen tablet. Okay, you need to tell me in your notes what y equals, what x equals. Show me the units. And then write down what your k equals, your constant of proportionality. Now that information was given by 16 miles for the hare for every 4 miles of the tortoise, and we simplified that. Go ahead and show me that in your notes. And then show me in your notes whatever math you did to get your data points, and clearly show me how you got the equation for your proportional relationship. Do you have all this in your notes? Do you have your table with x and y? Do you have what y equals, what x equals? Do you have the proportional relationship that you calculated from the data given? And do you have the equation for this proportional relationship? Great. Now let's go back to the GeoGebra page and graph this. Okay, so this is pretty easy actually, because they gave us a data point right from the beginning. It is 16 and 4. I mean, y equals 16 when x equals 4. So that's right here. X equals 4, y equals 16. What that means is, I'll say again, the tortoise ran 4 miles when the hare ran 16 miles. They also gave us the equation of the line. So if x equals 1, y equals 4. Let me do the math for you, just in case you're a little confused how I'm getting this out of nowhere. So I'm writing y equals 4, and then the value of x here. And so if x equals 1, then y equals 4, because 4 times 1, I'm going to use a dot for my multiplication sign. 4 times 1 is 4. Let's plot that on the graph. There. Okay, what about if x equals 2? Then it's 4 times 2. And that equals 8. Plot that on the graph. Another way you can do this, if you don't actually want to make a data table, well, you need to this time because I asked you to. But you could just look at this 4 and remember that is the slope of the line. That means for every 1x, we go up 4 units of y. That slope is rise over run. So starting from the origin, 0, 0, rise 4 and go over 1. Now look again. I said rise 4. Now I'm using the unit 4, not 4 spaces. I'm using the unit 4, not 4 spaces. Rise 4 over 1. Rise over run. There we go. I'm using the units here 1, not 1 space. So don't go 1, 2, 3, 4, and then over 1. No, that ignores the scaling. You have to pay attention to the scaling. Count your slope as you go with the scaling. Okay, anyway, let me go back to counting this with just using slope. Okay, I go up 4 over 1. Up 4 over 1 more. Uh-oh, I must have an error because that point's not on the line. Did I plot that as 1.5? Oh no, that was supposed to be 2. I caught my mistake. You can check yourself this way. Okay, I caught my mistake. That was a mistake. I looked at the wrong point. So try using the table and then checking yourself. Okay, up 4. So from 8 to 12 is 4. Just look at the graph here. From 8 to 12 is 4. Up 12 and then over 1. Look here. From 2 to 3 is 1. And then plot your next point. Up 4, over 1, plot your next point. And then draw a line to show the graph right there. If you have done everything correctly, all of your points lie on the line. If a point is off of the line, you've made a mistake and you need to check your work. Okay, it says, let me make sure I have completed this problem. Graph this relationship. Okay, here it is. I graphed the relationship. In the notes, there is a table showing this proportional relationship. Make sure you have your notes complete. I'll be checking them. Let's keep going. Next problem. The table shows a proportional relationship between the weight on a spring scale and the distance the spring has stretched. Complete the table. Okay, we have distance versus weight in newtons. Oh, I love physics, don't you? Imagine here is a scale, and the scale is measuring newtons. Here is a spring coming down from the scale. And when you place a weight down here, the spring stretches. So this is the distance of the stretch for the first problem, or the first data point, I'm sorry. It is 20, don't forget the units, 20 centimeters. And the weight is 28 kilograms, not kilograms, newtons. N for newtons. Okay, let's go ahead and put this in our notes. So on your notes now, please write problem 2. Let me change colors. The blue is good, but I'd like a thicker dot. Okay, please put in your notes. Problem 2, please try to write neater than me. I'm so sick and tired of my pen tablet. It's just only better than the mouse. Okay, remember what we learned? There is a spring scale. It measures newtons. Oops, not a straight line. I made a mistake. That's supposed to be a spring. Okay, wait, here we are. There's my spring. And then we can put a weight on that spring scale. Now, they measured the distance of the stretch. And we have a data table. Let's complete the data table. On the left side of the data table is centimeters, and I want to call that our x value. And then on the right side of our data table was newtons, and that's going to be our y value. Even though we're not graphing this, that just helps me think of it. And then think of the equation for this relationship is going to be y equals some constant of proportionality, that's a k, times x. And the first data point they gave us was a 20 centimeter stretch for 28 newtons. Put that into your table. X stretched 20 centimeters, and the weight was 28 newtons. You know what? I don't want to be like a real downer, but I think they made a mistake because newtons measures force, not weight. My phone's ringing, but I'm going to ignore it. I think my son can answer that. Hold on, let me shout to him. Cameron, your friend's calling. Cameron, your friend's calling. Okay. He gets the same phone calls on his phone as mine. Okay, sorry about that distraction. I didn't want to stop the video. Okay, next they've given us another data point. It is 55 centimeters, but we don't know how many newtons there. 55 centimeters, put this in your notes. Then they gave us another data point. You know what? Wait, I'm not going to do that yet because I'll probably get confused and make a mistake. Okay, so first, let's figure out what our constant value is. Our proportional constant is going to be the change in y for every change in x. So for 20 centimeters of spring, that's on the denominator, 20 centimeters of spring was 28 newtons of force. They said weight, but honestly, that's a force. That's what I always read in my physics books. Now, I chose to call this x and this y. I don't know if it should be the other way around. Maybe it should, but it matters as long as I keep it straight in my head. I mean, it matters, and I must keep it straight in my head. So don't forget, I said y is newtons, and I said x is centimeters, the distance pulled. So keep track of your units. K equals the change in y for every change in x. So how many newtons for every centimeter? You could do your units the other way around for your proportional constant, but you must keep track. Anyway, we're just filling out the table. So this is our proportional constant. Let's go ahead and simplify that. 28, if I split that in half, is 14. 20, if I split that in half, that's 10, but that's still not reduced. I can reduce that down farther to 7/5. So that means for every 5 centimeters of spring stretch, there are 7 newtons on the spring. Okay, now our next number is we have 55 centimeters of spring stretch. So how many newtons would that be? Okay, here's where units become really handy. 55 centimeters, if I just multiply that by my proportional constant, 7 newtons, make sure you're doing this in your notes, don't just let me do all the work. I'm going to multiply this by our proportional constant. And this makes sense because y is the newtons. Newtons equals k, our constant of proportionality that we've got here, times the distance of the spring stretch in centimeters. So basically I'm going y equals x times k. You can do it backwards. K times x, x times k, whatever you want. Okay, have you got a calculator handy? What's 55 times 7/5? Oh, let me think. Well, I'm just going to reduce this. That's going to be 11 times 7 because the 5 here cancels out and this becomes an 11. I'm pretty good at reducing fractions. So 11 times 7 is 77, and the units of that is newtons. You can check the units. If you have the units correct, if you did it correctly, your units will cancel out. See these centimeters here? That's on the denominator. And these centimeters here in the numerator, they cancel out. So what you're left with is the units of newtons. So you can check your units. That's called dimensional analysis, and you'll do that later in high school. Anyway, you can just remember the word now. So the y equals 77 newtons. Let's fill in the data, 77 newtons. I'll go ahead and fill that in here too, 77 newtons. Okay, next they give us 140 newtons. So if we have 140 newtons on the spring, how far will that spring stretch? Let's solve for that. Okay, I'm going to use my formula here. So the y equals 140, and that's 140 newtons. I'm going to go ahead and put my units there. Equals k, my constant of proportionality. Let me just write that in. K is 7/5. My units disappeared. There we go. And that 7/5 means 7 newtons for every 5 centimeters. Put your units in your notes. Don't be lazy. Put in your units. And then what is x? Okay, so let's solve for x. Are you any good at fractions? Can you solve for this? Remember, you want to get x isolated all by itself. So whatever you do to one side, you have to do to the other side. I want to get rid of this 7/5. I want to move that to the other side of the equal sign. So I'm going to divide this whole side by 7/5. And if I do it to this side, I have to do it to the other side to keep my equation balanced. So what I get is 140 newtons, I'll put my units there, divided by 7/5. And remember the units of that was 7 newtons per 5 centimeters. That equals x. Are you good at dividing with fractions? Do you remember that when you divide a fraction, you need to multiply by the reciprocal? Let me write that cleaner. There we go, 140 newtons. Now, divided by a fraction is equal to multiplying by the reciprocal. So the reciprocal is 5 centimeters over 7 newtons, and that equals x. If we have done this correctly, then the units will end up what we want them to be. 140 divided by 7 is 20. And these newtons, they cancel out. Because there's a newton on the top, there's a newton in the denominator, They cancel out. That's the same as newtons divided by newtons. Well, anything divided by itself is always equal to 1. That's how these newtons cancel out, because anything divided by itself is equal to 1. Okay, so 140 divided by 7 gave me 20, and I still have that 5 over there. 20 times 5 centimeters. Oh, you know, I did an x, but that's confusing, isn't it? Because we're solving for x. Let me just use that eraser. I don't like it that I left that x there. That was definitely my mistake, because that's confusing for notation. I should have used a dot. There, 140 times. A dot means to multiply. You're going to need to use a dot a lot. Don't confuse it with a decimal point. Don't use x's for multiplication anymore. That's what we're solving for. Okay, so anyway, 20 times 5 centimeters equals x. Twenty times 5 equals 100. And we have these units in centimeters. Keep your units there. Show me the units, because that's how you know you've got the correct answer. If you had the units of newtons, that wouldn't be a distance. You need the answer to be a distance that the spring was pulled. So it makes sense that the units end up as centimeters. It wouldn't make sense to be anything else than centimeters. Okay, our answer is 100 centimeters. Does that make sense to you? I think it does. 100 centimeters is our answer there. Go ahead and fill that in. And then one more. When the spring is stretched 1 centimeter, how many newtons is it? How many newtons of force? I'm really angry at them that they said wait. Maybe I'm going to change that. I didn't make these assignments, but sometimes I change them. Anyway, if I pull that spring 1 centimeter, how much force am I pulling with? Let's calculate it. So our data point is 1 centimeter, and I'm calculating how many newtons of force that is. Okay, go ahead and write your equation. The y is newtons of force. It equals 1 centimeter, that's the x value, multiplied by our constant of proportionality, which was 50, what was it again? Oops, 7 newtons. I used 55, but that's not at all correct. That was some value from my last thing. The constant of proportionality was 7 newtons. Don't forget your units. I had to check again. 7 newtons per 5 centimeters. Okay, well, this one we don't even have to rearrange it. It's very easy. So basically, we see 1 times 7/5. Look that the centimeters cancel out. You have centimeters on the top, and you have centimeters on the bottom. What is anything divided by itself? Centimeters divided by centimeters, that always equals 1. So they just cancel out. That's just like saying 1 times 7/5. Anyway, get rid of it. And your answer is 7/5 newtons. Y equals 7/5 newtons. Would you like to reduce that, or change it to a mixed number? Instead of leaving it as a fraction, let's turn that into a mixed number. 5 goes into 7 one time, and there'd be 2/7 left over. So 1 and 2/7 newtons is your answer. Go ahead and put that into the data table. 1 and 2/7. Please write yours neater than mine. Now you're going to be typing that in, actually. Let me help you with that. Type it like this, 1 and 2/7. Then it's easy to see you have a fraction there, 1 and 2/7. Okay, the next question says, describe the scales you could use on the x and y axis of a coordinate grid that would show all the distances and weights in the table. Okay, I showed you how I used it, how I made my scale, but what would you do? Let's say that this is our graph, and we have the y values here and the x values here. What would you use? I used x is centimeters that the string is, not string, spring, centimeters of stretch in the spring. And I used y is newtons of force. Let me erase this. So what I'm saying is, as you pull down on the spring, you can measure how many newtons of force you're pulling with. That's what I used for my scale. They called it weight, but I don't like that. Newtons are actually a force. You could compare it to weight, but it measures force here on Earth. And then x is equal to centimeters. That measures our distance of spring stretch. Okay, describe the scales you could use on the x and y axis of a coordinate grid that would show all the distances and weights in the table. Now they're asking scales. We already decided what we're using for x and y, but what is the scale? Okay, x needs a range from 1 to here, 100. 100 is the largest value in our data table. So x needs to go all the way out to 100 in order to show all the data points. And the y needs to go, this is a 77. Do you remember that? Very messy. Y's lowest value is 1 Newton and 2/7, and its largest value is here, 140 newtons. So our y value needs to go up to 140. If so, now we can plot all of the points. And this always starts from the origin. That's 0, 0 there, 0y, 0x. That's called the origin. Do you want me to plot them really quickly? You know I'm dying to. Okay, so x equals 1 and y equals 1 and 2/7. That's going to be really close to the origin, something like that. When x equals 20, y equals 28. So that's going to be about here, I think. And then the next point, when x equals 55, y equals 77, that's about half of this distance, barely over half, and barely over half of this distance, so right about here. And let's plot the next point. 1, 2, 3. Am I missing one? Here we are, the largest point. Okay, at 100 centimeters, the force on the spring is 140 newtons. If I have plotted these correctly, everything would fall onto a line. It looks like I did a bad job. Things are a little bit off the line. But anyway, I don't even have a grid to help me, and I'm using this pen tablet. Please put this in your notes. I want to see your little hand-drawn graph in your notes, please. And please type your answer here. What is the scale that you're using? Would you like me to help you with that answer? Let's say x equals the distance the spring is stretched. The x scale must go up to 100 centimeters. Y equals the force in newtons, and the y scale must go up to 100 and 40 newtons. Okay, type in your answer, guys. Make sure your notes are complete as well.